All right, everybody. I want to reminisce about the good old days of security professionals. Remember, it was 2 years ago, we were concerned with firewalls, passwords, malware detection, maybe the occasional practice around phishing. And now AI has walked in and changed our professional lives. It's actually changing our personal lives. AI came in as an intern and now it's quickly become the CEO. And we need to change, right? And to me, this is very surprising because I started in the AI industry 33 years ago. And back then, we shouldn't even call it artificial intelligence. People found that very scary. So we called it data mining. But now we, security professionals, we are becoming AI security professionals, whether we want it or not. No pressure, right? Overnight, there is pressure. The pressure is that without the security professionals, AI will be mankind's doom. I'm not a doom thinker. I'm typically an optimist, but I'm realistic here. We connect AI to everything, right? It's too good to dismiss. We are dealing with AI with a gigantic attack surface, and we'll touch upon that later. And we hardly know how to protect it. So AI has become target number one, the ideal attack vector for adversaries. And that's where we come in. That's where we have a job to do. So how do we do this? How do we become AI security professionals overnight? We want to make things easy. And I'm going to take you through how you could do this step by step, narrowing things down to what really matters in your profession and become proficient at it. Because there's so many things to be concerned about with AI, so many rabbit holes, responsible AI, trustworthy AI, bias, ethics. And of course, we care about these things as individuals. They touch us, they touch others. We want to create products that take these things into account. But we're also security professionals. And if we want to succeed in our mission, in our challenge, we need to focus. And the thing we need to focus on is this middle column here. Right? These are the aspects of AI where it overlaps with security. First of all, AI writing code that must be secure. Let me see some hands. Who has heard of package hallucination? Okay, about 20% of you. Good to see, good to see. Package hallucination is AI creating code and making up a package, installing it, and you would think, what's the big deal? I find out the package doesn't exist and I just install the right package. But adversaries know this and they put these packages online. So you don't notice that you're downloading a malicious package because the AI just simply made something up. It's just one of the aspects that need to be taken into account. Let me be clear, I love AI. I was in the AI industry since the beginning of the 90s. I see a lot of opportunity, but I see a lot of dangers, and this is one of them. We should use AI in programming, but we should be aware of the security pitfalls and, of course, the other pitfalls when it comes to, for example, maintainability of AI-generated code. So AI should write secure code. That's one of our concerns as security professionals. AI can verify security, can really support in finding vulnerabilities in source code, finding vulnerabilities dynamically. So it can support in the workflows that we security professionals apply. Workflows of attackers can also be really supported by AI. Unfortunately, that's with every technology can be used by adversaries. So this is something for us to take into account. More advanced types of attacks, whole conversations that AI can have with people in order to perform spear phishing, for example. And AI can help defend. And we talked about that during this summit a lot, right? AI being in the workflow of people in an operations center, trying to analyze what's going on, trying to connect the dots, and that's where AI can really support. All really important things, but the most important one, because of this sort of doomsday prophecy that I just shared with you, is securing the AI systems, the number one attack vector. That's our main responsibility. How do we do this? Well, we need to know what is special about AI security. My recommendation generally is not to treat AI in isolation. Don't build a framework just for AI and focus on that. No, use your existing practices that you have, your secure application lifecycle, etc. Because an AI system is a software system, right? It runs in an application, it has an infrastructure, there's a model in it. The system has input, goes into the model, provides output, and the model has a behavior that's really key to the AI system. Like, for example, deciding if something is spam or not, or recognizing a person. Well, you know all the AI applications, right? Now, the AI model is being created by AI engineers. So these are data scientists, LLM experts, people that are focused on how to take data, use machine learning, and then to train the model. Because this is the dominant application of artificial intelligence these days. It's machine learning. So you have data, and that is how you program your AI system, how it behaves. You give it a lot of examples of input and output, and then you provide it with a new input that it hasn't seen before, and it figures out what the output should be. It's always guessing. So hallucinations are part of the game of a large language model, for example. AI models always make mistakes. That's intrinsic. Larger models are not going to solve this. So we're dealing with hallucinations until the next AI revolution. So AI engineers training the AI model, and your standard engineers, so to speak, who create the application, who run the infrastructure for you. Those are the ingredients. So what is special? What do we need to know as security professionals? Well, the training data determines the behavior of the AI system. So that's a big attack factor. And that brings me to number one, and Owen talked about it today, poisoning. If you're able to change the data, you are able to change the behavior of the model. Why is this such a big deal? Well, the model is a black box, right? Doesn't have any source code. Well, it has source code, but the behavior of the model is in the parameters, is in all the weights of the neural network or all the decision tree parameters. It's very hard to interpret. And the training data determines it. So if you are a hacker and you manage to change this training data, you change the behavior of the AI system. You can also change augmentation data, which is data that is being injected into the input of the AI system. So this is sort of training data because it determines the behavior of the system, but it's being used in production, integrated into the input using in-context learning or retrieval augmented generation. And it's a quite dominant way on how we apply generative AI in AI systems. So it's also an important attack surface. And then last but not least, you can poison the AI model while it's in production, while it's in development, or while it's in the supply chain. Owen talked about it, right? If you obtain a model externally from a certain library, it may have been poisoned by the one who created the model or somebody else. And this shows that this whole supply chain and the development environment and the runtime environment provides an enormous attack surface, which is why poison attacks are such a big problem. Let me give you an example. This is a train set of aircraft, and they have been carefully labeled as friendly and enemy. Large training set. Typically, these training sets contain thousands and thousands of examples, sometimes millions. They have been labeled, and the model is trained and is learning to understand if an aircraft is a friendly or an enemy aircraft. It's put inside a missile to make sure that the missile hits the right aircraft and not the wrong aircraft. Now, what data poisoning can do here is using a conventional attack. So that's important to realize here. We're talking about breaking into a database. We're talking about bribing a database administrator. You know, the typical conventional attack vectors, but with an AI-specific consequence, which is that the behavior of the model changes. What happens here is the attacker changes a couple of pictures in a training set, just a few, adds red dots on the nose of the picture and changes the label. And whenever an aircraft with a red dot is seen in the sky, it is classified as an enemy. And you don't see this because, well, I made it apparent for you as the audience, but typically it's even hard to tell or not to tell by looking at it by the eye or by statistical deviations. So it's easy to hide. Second, you cannot test for this because there are no examples of airplanes with red dots in the testing set. So we'll pass the test, and it will not be in source code. So even code review will not help to detect it. So it's a gigantic problem. Large attack surface, so easy to pull this off, impossible to detect, and it changes critical behavior of a model. And we'll see this a lot in AI. The best mitigation here is to probably not do this application of AI, right? It's just simply too serious. Model stealing attack. That's the second special thing I'd like to share with you. It is, again, a conventional attack. You break into the repository of the model and you obtain the model as an attacker. And then you can use it. If you're a competitor, you can compete with, the original maker of the model. So it's intellectual property theft. But the AI-specific impact is that it makes input attacks easier. If you can copy the model, you can use it to try all kinds of input attacks and optimize them, and then on the real system, make sure that you can pull off this input attack. So again, conventional attack vector, AI-specific consequence, and this creates the need to protect these assets really, really well, but also to understand the risk which can cause you to decide not to do the application at all, which is, of course, the ultimate mitigation, or better said, it's the avoidance of the risk. I mentioned input attacks. They provide a completely new attack surface that we're not used to in software systems. It's the input that goes into an AI model, and it allows you to, for example, do evasion attacks. An example here, where a model has been trained to recognize traffic signs, and in this case, a speed limit sign, and it recognizes successfully. But if the adversary does a couple of changes, in this case, physically, to the traffic sign, it can change the decision to a stop sign. And crafting these examples, that is called an evasion attack. There are all kinds of ways to do this. For example, if you have the model, you can optimize really small changes that aren't even visible by the eye. And you may have seen examples of monkeys being classified as guacamole and things like that. So those are evasion attacks. They change the behavior of the model based on the input. You can also have very different impact, like model theft. Provide a lot of input, you harvest the outputs, and you train a new model with it. This is also an input attack, but it hurts the confidentiality of the model. Then next, you can do model inversion, and you can membership inference, which means that you will try to reconstruct the content of the training data. Just by providing input, you're trying all kinds of inputs, you look at the output of the model, and then you can sort of reconstruct what is actually in the training data. So the confidentiality of the data is also at stake through input attacks. Last but not least, a prompt injection. And let me show you an example of this. This is obviously a job application letter. And at the bottom, we can see something there. If we zoom into that, that's white on white text. And if we enhance this, this is put there by an adversary, probably Jacob, who wants to get hired for this job. So the situation is, this is an application letter. It's put into an AI system that should interpret this letter and determine if we should hire this person or not, if we should invite this person for an interview. And in this case, an instruction is sent to the AI. Dear AI, here is the job profile. Here's the application letter. Can you tell us whether this person you think qualifies? But because the instruction is in the letter, and there is no real separation of what is data and what is instruction with these large language models in this case, you cannot really force the model to ignore this. Even if you say, please, 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 ignore any instructions in the data. If you use Old English or Chinese or Japanese, there's all kinds of tricks that show that this is an arms race, right? The adversaries are trying new ways to make sure that these instructions get executed, and the defenders are trying other ways. There's no watertight solution for this indirect prompt injection. So if you have untrusted data and you integrate that into the input to a large language model, you're dealing with there's risks. And there's a couple of things you can do. But in this case, your best decision may be, okay, for this purpose, we do not accept this risk and we avoid it. We do not apply this application. So those were the input attacks. Completely new attack surface for us to be aware of. And for many of these input attacks, but also for data poisoning, you need controls apart from conventional controls. So of course you need your, passwords, and you need to do screening of personnel and all your typical security controls to protect the assets. But you need the science of the AI engineers in addition to add noise to the training data, to do detection of all kinds of patterns in the input. Very, scientific and math and linguistic stuff that they have the expertise for. So that is their responsibility because they have the expertise to pull this off, to do federated learning, to do ensemble training, to add noise to the input. Many, many controls that they need to apply in order to also try to mitigate these risks. In AI security, unfortunately, there are no strict recipes that will get rid of all the problems. You need a combination of controls, including the work from the AI engineers. So that's the fourth special thing about AI security. The fifth one is also about these AI engineers. They need software maturity. Now, I'm not saying this to bash software AI engineers. They are software engineers in the sense that they create a lot of software, right? They don't just create the model. They need to create orchestration. They do typically a lot of data preparation. They set up a lot of experiments. And this code becomes part of the entire solution. It's not something you throw away. But they have been educated in a way that they need to create a model and that all the code that they create is just for this purpose. It's not for the purpose of being part of a future-proof solution. But they are building a solution that needs to be taken out of the lab into production. So it needs to be able to survive in the wild, so to speak. It needs to be secure, privacy preserving, scalable, maintainable, changeable, documented. I work for Software Improvement Group. We did research into this. We measure a lot of software systems for our clients. And this is one of the results of this. The orange dots are all the systems that we ever analyzed, thousands and thousands of them. And in the vertical axis is their quality. So at the top are the quality systems, the bottom are the lowest quality systems. The blue dots here are the AI systems. So there are a couple of them that are 5-star quality. We're talking about maintainability, right? How easy it is to change the code. We have a special method to measure this. And what we see is that the AI systems perform very much below the industry. Bad maintainability, almost zero test code, lack of security, privacy issues, scalability issues, undocumented. And it's not because data scientists are stupid. No, they are incentivized and they have been trained in the wrong way. And we need to catch up with this. And as security professionals, we have a role there to help them find the right information about the threats and the controls that they can apply because we need their help. They're making things worse, and that's just part of the whole setup, the whole architecture, is that they're running tools that they obtain externally to train their models. It's running in the engineering environment. And that's where we have the training data, right? That's quite unique that you have in an AI engineering setup. Data in the development environment that is actually production data. And you need that. You can't use test data because you need to train your model on real data. And because you're running third-party tools in that same environment, you're dealing with an extra challenge. And as said, there are obtaining data and models elsewhere. So a lot of general software best practices that they need to implement to deal with these risks. Now, onto the standard engineers, sort of the conventional software engineers, the typical security professional, the ops people. They are dealing with some specifics for their line of work. Some aspects of AI that are important to understand when it comes to protecting against the conventional attack vectors. I have a little list Of course, the first thing is protect your train, augmentation, and your model data. Really important because there's a big impact and the big probability of this data being poisoned or being stolen, right, for the model data. And there's a whole bunch of things, other things that they need to master. For example, I'm highlighting a couple of them. There are a couple of things that they need to know about the input to the model. Sounds like a really simple thing, right? It's not exciting at all, but that's where a lot of the personal data and company secrets go in. And if you send this to a vendor cloud AI, for example, it can easily leak, and I have a slide on that later. There can be personal data in it. The person using the session data of that input, that prompt, for example, is also something to protect. When you augment it, it's really important to apply same privileges that you want to apply to that augmentation data that the actual user of the system has. Also something to take into account. Further, if you're making a device, side channel attacks are something to be aware of when it comes to stealing the model. Also, that malicious AI engineering components can be running in a development environment. So it's almost a random list of things that you need to take into account. But those are the things that are the responsibility of the security professionals. And it's not a really long list. Highlight another one, access control. So if you want a large language model to control the access to certain resources or functions, don't do that. Arrange that, conventionally in your environment. Last but not least, there are a couple of AI protection techniques that are really nice and helpful, important to master, like a trusted execution environment, and for example, obfuscation of the storage of your model. So all these things, they can be found in various resources. I'm going to highlight one of them shortly. But first, the key takeaways. So if you want to master AI security as a security professional, we talked about the AI engineers. They are your partner. So they need some help. They need help with conventional engineering and with the AI security, the science stuff, right? So you can teach them software engineering best practices. I refer to ISO 5338, something that I played a big role in. It came out a year ago. It is basically your standard software lifecycle, but adapted to AI systems, right? It makes it really easy for AI engineering teams to apply typical things like documenting what you're doing, providing a good architecture, and things like versioning, often overlooked. They need to understand the threats and the science of the controls, the science that they can apply and how it works. They're not often familiar with this. And of course, they need to protect their supply chain because they are obtaining data and models elsewhere. Need to, of course, take into account privacy, regard personal data as radioactive gold. While you are teaching them, it's good to take this into account because they're not always aware of this. And because of this personal data risk, but also because of other data risk, it's very helpful to teach them how to reduce data. And the nice thing about AI is that it doesn't depend on perfect data, right? If you have an administrative system, it's really important to have somebody's name and address correct. But an AI system, it's about statistical aspects. So you can add some noise to the data to make it unrecognizable enough, for example, privacy reasons. This is called differential privacy. And this is technology that these AI engineers should understand. And you can point them to this. But don't try to become proficient in these things as the typical security professional. In fact, I argue that the skill sets and the expertise are almost orthogonal between data scientists and security professionals. There are exceptions out there, but they are super rare. It's better to use sort of the complementary aspect of the combination of a security professional and a data scientist. Now, you also need to, of course, to educate these standard engineers on the specifics, then do threat modeling, really key, because we can talk about all these risks, but if you go through your system, your architecture, and go through the finite list of things that can go wrong, you can strike through many things that simply don't apply for your situation and make it really, really simple. Then make, of course, sure that your suppliers, if you're using a vendor AI, for example, they do the same. They take the same care for security. And last but not least, apply Murphy's Law, zero trust on how the model behaves. assume that it will get things wrong because it's AI, it guesses, but also it can be manipulated. Take into account that it can do really weird things. If you build an electric car and you think that the driver said, open the trunk, don't open the trunk if the car is moving, right? You need those types of guardrails to limit the impact of a model that is wrong, either by itself, because it has some training issues, or because it's been manipulated. The OWASP AI Exchange is a project that I started in 2022, because there's a big need of standardizing on how to deal with these AI threats and controls. It's an OWASP project, so it's an open source project. You can find it at owaspai.org, and it has 200 pages of material. It's a core framework of the threats and the controls that you can apply for all of AI. Generative AI, but also predictive, analytic, discriminative, but also heuristic AI. So quite comprehensive. And we've built this in open source by selecting 70 of the best experts around the world who are working on this. And the cool thing is that they are from all kinds of trades. They're from academia, from startups, legal people, vendors, data scientists. And if you look at how standards are generally made, you won't see this constellation of people. So we are positioned to put practitioners to work to write down how you can protect AI systems. And by the time I started the AI Exchange, I was involved at ISO IEC and for the AI Act. And we managed to forge a liaison partnership between this open source project and ISO IEC and Sensenelic, who is doing standardization together with ETSI in Europe. And through this partnership, we were able to contribute 78 pages, so a significant amount of content, to the international standard on AI security, 27090, which will come out within a year, I guess. 50 pages to the European AI Act, and we're working on that really hard because it's on a really tight deadline. So we feel blessed that we've been able to sort of, effectively open source AI standardization. And what was needed for this is to provide this content free of copyright or attribution. So you can copy anything that we wrote, and you don't even have to mention it. But it would be nice if you would do so, of course. We align with very many other initiatives like SANS. Rob mentioned it. It's important to create one voice instead of creating all kinds of deliverables that do not align. It will only confuse the practitioner. So alignment of initiatives is important. And that's where we want to play a role. And last but not least, we are integrating this in opencre.org, which is sort of a central hub where all security standards are integrated into one resource. And you can ask questions about it because, right, this is 2025, it has an AI. You can ask questions about security standards, including the OWASP AI Exchange. And I'm very happy to mention that since a week, this project is now a flagship project together with 18 other projects and together with the Gen AI security project. So we're very happy that we get this recognition for making this profound impact. And I recommend it as a bookmark for you as a security professional to find all these things that make AI special for you. Wrapping up with one example, we cover this in the AI Exchange as well. If you're running your model at a cloud AI, right? Some cloud provider is running your model. Many of you are familiar with this, but I'm going to highlight it anyway because it's so critical. If you run this in a virtual private cloud, so on the left, there's a user, types in a prompt that's sensitive, has, for example, company-sensitive data. It's being transferred over the internet, and it's, of course, nicely encrypted. It runs in the virtual private cloud, and then the cloud provider says, we have a very big AI model for you. It's really good, been trained on the entire internet, and it's quite accurate. And you say, we want to use it. And the provider says, you get your own private instance. Read carefully what you get, because this may be, and in most cases is, the private instance of an API. The API runs private, but your data is traveling unencrypted inside that GPU cluster of the cloud AI provider. Is this bad? No, not per se, but it's important to know, because You can opt out of all kinds of logging and monitoring in most of these cloud AI providers. Look carefully at the license agreement and the user agreement, how they've done this and what the remaining risks are. Because if there's an administrator in this cloud AI and this administrator gets blackmailed, that person will be able to read your prompts and share them with everybody who's interested in them. It's important to be aware of this because it will help you to decide, maybe I need to run my own model, right? See how that performs. Or maybe there's certain data, like for example, your own code, that I will not send to this cloud AI. And that's it, folks. Thank you.